Okay, in this video, we're going to talk about how does a calculator find the square root of a number. Okay, and so if you have a calculator and you press, let's say 25 and you press the square root sign, well, you know it's going to come up with 5 because 5 times 5 is 25. But suppose you come up with you have another number. Suppose you have 498.6. You take the square root of that. What is that? Well, you don't know. And you need a calculator to do that. Well, how does the calculator do that? Well, that's what I'm going to show you. Because even though you think it's not important, it is. Because that cell phone you enjoy every day, it has to know how to do that. Okay, so let's talk about that. How does the calculator find the square root so quickly? Well, mathematics is supposed to not only make your life easier, it's also supposed to help you create wealth. Most people don't even care about finding the square root of a number, and I understand. The majority of the time, your life does not depend upon the square root of a number. Can you discuss one time in your life a circumstance involved you knowing how to find the square root of a number? Not even one situation can probably come to mind unless it was in your school days. But that cell phone you depend upon daily, the people that design it, and the satellites it communicates with need to know how to calculate the square roots. And so does a calculator. I remember when I first enrolled into mechanical engineering at Southern University, one of the first pieces of equipment I purchased was a calculator. I purchased a Texas Instruments TI-30 scientific calculator. Okay, here's my TI Texas Instruments calculator I had in 1976. This is a photo of it. And as you can see, the functions it had on it, basic functions, inverse x, x squared, square root, sine, cosine, tangent, log to the base 10, logarithm to the base e, uh, and that's about it. Y to the x, so that's the basic functions it had on it. Stove, which was the memory, pi, and so forth. Now, there weren't many functions on this calculator in 1976, but by the time I graduated and went to work in engineering in 1980, I knew how to calculate every function in engineering and statistics on a contemporary calculator. Now, here's a contemporary calculator of today, a Casio 115, which I use. And as you can see, there are much more functions on this calculator. Okay, let's get started. How does a calculator find the square root so quickly? Well, the first thing we need to know is that calculators operate at the speed of light. Also, calculators don't know any more than we teach them. At least at the moment, calculators cannot learn. So to calculate the square root of a number, we have to give the calculator a path to the square root. Since we know how to do it, we tell the calculator how to do it, and it does the job at the speed of light. This path is called an algorithm, such that when the correct numbers are entered, the correct answer is given. Let's see how this is performed. Let's continue. How does the calculator find the square root so quickly? Well, the first thing we have to know is mathematics. Within this mathematics is logarithms or natural logarithms. Logarithms are called logs and are to the base 10 and to the base e. The base e logs are called natural logarithms. We'll do both, but I won't teach you logarithms because that's an entirely long and complex session. But we'll just use the logs to get the desired answers by using a calculator. And I'll show you a few tips. Logs to the base 10 are written log to the base 10 of 100 equals 2. As you may know, the logarithm is the inverse operation to exponentiation. Therefore, log to the base 10 of 100 equals 2. The inverse is 10 squared equals 100 as an exponent. So the 10 is the base. This means that this log is to the base 10. That's easy. Now let's continue. The natural log. or natural logarithm. The natural logarithm is to the base e. I'm not going into base e other than to say yes, this is the same e on your scientific calculator, which is the e for Euler's number, which is about 2.7182, and it continues on. Logs to the base e are written. The logarithm is the inverse operation to exponentiation, as we said before. Therefore, as an exponent, x equals e to the y, and the inverse is y equals log to the base e of x. Well, the e is not placed there regularly, but I put the e there to let you know that this is a natural logarithm. When you see ln, you know that's natural logarithm. Sometimes people call this, rather than call it log, they call it Linux, which lets you know it's natural log. This means that this natural log is to the base e. Let's continue. What's so neat about the natural log and the log to the base 10? Well, there's something neat about this relationship, and I'm going to show you that. The logarithm, the word logarithm was made up by the Scottish mathematician John Napier, 1550 to 1617, from the Greek word logos, meaning proportion or ratio or word, and arithmos, meaning number, which together makes ratio number, which is the Euler number, which I said before, of 2.71828, and it continues on, where e to the 1 is equal to 2.7182818, and it keeps going. Okay, so that's what e is. So if you take the e on your calculator and put it to the power of 1, you'll get the Euler's number. But we write our numbers in base 10. So our numbers are written base logarithms or base 10. Log to base 10 of 100 is equal to 2. 10 squared equals 100. But our computers are designed to write numbers in base 2. So how do we convert from base 10 to base 2 or any other base? We use the natural log to the base e. Let's see how this is done. Let's write out the equation for the logarithm. So the logarithm equation is x equals b to the y, where b means base. So let's take the log to the base b of both sides, okay? So x to the b to the y, log of the base b of x equals to the log base b of y, okay? Now, per log rules, which you probably don't know yet, because if you don't know logs, but log to the base b of x is equal to y times the log base b of b. But the log to the base b of b is equal to 1 per log rules. Therefore, y is equal to log base b of x. That's log to the base b. Now I'm going to take the natural log to the base e of both sides. So we have x equals b to the y. We take the natural log of both sides. I still got the e there so you can know this natural log. So the natural log of x is equal to natural log of b to the y. Now, per log rules, we have y times natural log of b, natural log of e of b. So here's our previous equation. And then we divide through by natural log to the base b of e, and we get y is equal to the natural log of x divided by the natural log of the base b. Now we have two equations that's equal to y. Well, if they're equal to the same y, they're equal to each other. So we have the log of base x is equal to the natural log of x divided by the natural log of b. So now with this equation, we can find the base to any positive number. I placed the e, as stated before, on the natural log to let you know the difference. But as you can see, ln is the natural log. Let's continue. Let's find the logarithm of a number to base 3. Okay, So we have log the base 3 of 635. And what is that number? Well, we don't know. So we put a question mark there. So we take our handy equation we just derived. We say the log of the base b of x is equal to the natural log of x divided by the natural log of b. And all we do is plug in those numbers there. So the log of 3 to the base, excuse me, let's start that over. Log to the base 3 of 635 is equal to the natural log of 635 divided by the natural log of 3. Okay. We plug in the numbers and we get 5.87434262, and it keeps going. Okay. Now let's check the answer. Let's check the answer. So how do we check this? Well, we take 3 and we raise it to the power of the number we just got, 5.87434262. We raise that to that power. So 3 raised to that power is equals to 635. Okay, let's check that number. Yeah. Let's check that number with a calculator. So okay, we have the natural log right here. We're right here. So we have natural log of 635 parentheses divided by the natural log of 3, which is natural log of 3 divided by parentheses. Okay. And then we'll hit the equal sign here. Let me get my equal sign up here. Is equal to 5.874342, just like we had before here. Okay. So let me save that in here. Okay. Now, let me move this mic. This calculator is really huge, and I don't know if I can make it any smaller. Okay. So now let's raise this answer to 3. So 3 raised to the power of recall memory, 5.0 there. That's equal to, should be 635, or rounded off 635. There it is, 635, okay? And so that's to the base 3. So we checked our answer, and it came out the same, okay? Okay, now let's do one more. Let's find the logarithm of a number to base 4.6. Wow. Okay. Well, let's do the same thing. We take our handy equation we derived previously, and we plug in the numbers. Well, the base is 4.6, and the number we're looking for is 82. Okay. So the logarithm to the base of the log to the base 4.6 of 82 is equal to something. All right. So we take our handy equation, we plug in the numbers. We have the natural log of 82 divided by the natural log of 4.6, and we get 2.887651, so forth. Now let's check the answer. Well, what we got to do is we got to raise our base is 4.6. So we have to raise our base to this answer, okay? And you'll see we get 82. Okay, now let's check that on the calculator. Okay. So let me move that here. And we have the natural log of 82 divided by the natural log of 4.6. Okay. 4.6 in parentheses. Okay. And then we hit equal sign. Well, let's move my equal sign here. It's equal. And we come up with 2.876518. And that's the same thing we had up here. Okay. Now let's save this. Save this. Okay. Now let's raise 4.6 to that power. So 4.6. Oh, let me clear this. 4.6 raised to the power of recall memory and say equal 81.99974. Well, let's round it off because I didn't take all of the digits on my save right here. See, the digits stop there. So, uh, but it's rounded off to that number. Okay. So, let's see. Let me see. 4.6 raised to the power of recall right there. That's equal to 81.9999. Okay. Okay, so that's it. We checked that and it came out. So we can find the number of four. We can find 82. We say the log of base 4.6 of 82 is equal to 2.887658. Okay. Okay. So how does the calculator perform the square root of a number? To do it, to do this, the calculator uses logarithms. Let's do it. Let's investigate logarithms and discover how the calculator performs that task when we click the square root sign. We know how to raise a base number to a power. We just did that in using logarithms. So let's investigate powers and square roots. As we just did, we know 2 to the power of 6 is equal to 64. You know, if you raise that on your calculator, you should see it. Okay, and let's see if we can do that. Okay. Let me see if I can find my mouse here. Okay. So we have 2 raised to the power of 6 is equal to 64. Okay. So we know that. All right. We know 2 raised to the power of 6 is equal to 64. This means 2 multiplied by itself 6 times is equal to 64. Let's take the square root of that equation. We're going to take this equation and take the square root of both sides. So the square root of 2 raised to the power of 6 is equal to the square root of 64. Okay? But square root is really written as 2 to the power of 6 raised to the power of 1/2. That's what square root is. Okay? If you know your algebra, you'll know that. So then, according to algebraic rules, we can multiply the 6 by 1/2, and that leaves 2 raised to the power of 6 over 2. Well, 6 over 2, you know, is what? 3. Okay? So 2 raised to the power of 3 is equal to the square root of 64. Well, what's the square root of 64? 8 times 8 is 64, right? Let's continue. So our previous answer here is 2 raised to the power of 3 is 8. 2 times 2 is 4, and times 2 is 8. Well, 8 is equal to 64, the square root of 64. And so therefore we use logarithms to get the square root of a number. Square root of 64 is equal to 8. Okay, so I use a number we know the square root of to prove this point. But now let's use a number we don't know. Okay, find the square root of 456.7. So now we have 2 raised to the power of x is equal to 456.7. I said the power of x because I don't know what that number is. Okay, see here I knew it was 3. That's the number I needed. Okay, I knew it was 3. But here I don't know what the number is for 456.7. So I used an unknown number, x, a variable. I use an unknown variable, x. So now I take the log of both sides. So I take the logarithm, natural log of 2 raised to the power of x equals natural log of 456.7. Okay. And then I divide through by the log of 2, and I get x is equal to the natural log of 456.7 divided by the natural log of 2, which is 8.8351029, so forth, and keeps going. Okay. Then I divide by 2. And I'm going to show you why this is later. Okay. So I divide that by 2, and the number is x is equal to 4.417514. Okay. Our previous result is here. So, okay. So, therefore, 2 raised to the power of 4.175514 is equal to the square root of 456.7. After raising 2 to that power, we get 21.37 for the square root of 456. Okay. Now, let's do that on a calculator. Okay. So the square root, where's square root on here? Okay. 456.7 parentheses raised to the power of 0.5, which is 1/2, is equal to 21.37054, just like we had before. So that checks out. Okay. Let's do this on a real calculator, which we just did. Okay. With the calculator, let's find the logarithm of 82. The log to the base 4.6 of 82. Okay. And you'll see here that we had, let's follow this, the log of 82 parentheses divided by the natural log of 4.6 parentheses equals 2.887651. Okay, just like we had before. Okay, and then we save this to here, and then we clear this out, and now we're going to raise, what's our base? Our base is 4.6. So we say 4.6 raised to the power of, memory recall, is equal to 82, just like we said before. Okay. So now let's find the square root of a number. So now let's find the square root of a number. Let's find the square root of 456.7. So now we have 456.7. And what is that number? Well, as 2 raised to the power of x is equal to 456.7. Remember, we don't know what the number is that goes in the power. So we use x for the unknown. Okay, so now we take the log of both sides. Log of 2 raised to the power of x is equal to the log of 456.7. And that means, according to log rules, we have x times the log of base, log of 2 is equal to the log of 456.7. And we solve for x, and we get x is equal to the log of 456.7 divided by the log of 2. And that comes out to 8.8351029, keeps going. Now we divide by 2, and I'm going to show you why this is later. And so x is equal to 4.4175514. Let's continue. So our previous answer was this, and so x is equal to 4.4175514. Therefore, 2 raised to the power of 4.4175514 is equal to the square root of 456.7. Okay. And if we look at the square root of 456.7, the square root of, where's the square root? I'm looking for a square root sign on here somewhere. So anyway, Well, I thought I had a square root sign on here, but let me see. 456.7 raised to the power of, let me raise it to the power of 0.5. And that should be the square root, which is 21 uh 37054. Okay. And if we continue here, after raising, there it is right there. And after raising that to that power, we have the square root of 456.7 is equal to 21.37. Okay. And then if we square that, we'll get 456.7. So why did I divide by 2? Well, I'm going to show you that. Let's investigate that. You remember last time I said 2 raised to the power of x is equal to 456.7. That's what I did before. But this time, let's take the square root of both sides of this equation. So take the square root of both sides. Okay. And now, the square root is really equal to one half, raised to the power of 1/2. Okay. So it's the same as raising both sides to the power of 1/2. So, and I can multiply the x by 1/2 per algebra rules, and then I can take the log of both sides. Okay. And then here's my last previous equation. And I take the log of both sides, that's x over 2 times log of 2 times 1/2 times the log of 56.7 per log rules. And then I multiply by 2, and I get 2 over 2. And x is equal to log of 456.7 divided by log of 2, which is 8, x equal 8.83. Now, when we plug x back into our original equation, guess what? X is divided by 2. Okay? That's why I told you divide by 2 last time. So we see x is divided by 2. So 2 raised to the power of 4.4175 is equal to the square root of 456.7, just as we did before. Let's continue. Hey, it's not magic, it's the law. Mathematics is fun. Until next time, I hope you learned something. I enjoyed it.